So today, when we jump back into polynomials, a lot of the words that you see on the board and on your notes look familiar. Solving, factoring, polynomials, right? Because we're doing those things again. We're still factoring, we're still solving. The difference today is we don't have any binomials today. We don't have any trinomials today. These guys have 4 terms. They have 4 terms. So if there's 4 terms, we can't use the steps for factoring polynomials or factoring binomials and factoring trinomials because those steps won't work. How can I use the ABC method if I have more than ABC, right? So there's another method. It's called grouping, okay? It's called grouping. So these are the steps. I put the steps on the board too, okay? So this is what we use when we're factoring or solving things with 4 terms. It's another method, okay? So let's look at example number 1. Okay, example number 1. Example number 1, we've seen the title, we've seen the direction, you see, factor each polynomial completely. You've seen that before. Just in the past, it was a binomial or a trinomial, so we use those steps. But now, this guy's got 4 terms. This guy has 4 terms. Has 1 term there, 1 term there, 1 term there, and then it's got a last term there. It's got 4 different terms, right? So we can't use those steps. So we use what's called grouping. So the first step of our grouping is factor out a total GCF. So all of those 4 terms, is there a GCF among all of them? Besides 1? No, there's not really, right? The first 3 terms have x's, the last one doesn't, so I can't divide by x. And then 1, 1, negative 25, negative 25, I can't divide by anything other than 1, right? So there is no big GCF, okay? But we can make sure it's in standard form. So is that guy in standard form? Yeah, it's already, right? Starts with the biggest power and then moves down, right? Okay, so erase these. So we move to the next step. Since we can't do ABC, we can do what's called grouping. So what I'm going to do is I'm going to group this guy into 2 groups. 2 groups. I'm going to put the first 2 in a group. So the first 2 I'm going to put in a group. And the second 2 I put in a group. Okay, plus sign in the middle. Always plus sign in the middle. Okay, so now they're in 2 groups instead of 1 big group. They're in 2 different groups, 2 smaller groups. So the first thing I'm going to do is I'm going to look in the first group of 2. Do those guys have a GCF? Do these 2 guys, the 2 in the first group, do they have a GCF? Is there something I can divide both of these guys by, either number-wise or letter-wise? What do they share in common? X squared, right? So I can divide by x squared. Okay. So just like I normally do, x squared goes in front. When I take away, I'm taking away 2 powers from everyone. So I took away 2 powers from x to the 3rd, that just leaves x. And if I take away 2 powers from here, it doesn't have any x's left. So what's left? Not 0, close. 1, yeah. Anytime you divide anything by itself, it's always 1, right? So when you're dividing something by itself, it's always going to be 1, okay? All right, so now we're going to do the same thing with the second group. So here's the next group. Does that have a GCF? Does that have a GCF? Negative 25. So I'm going to divide both by negative 25. Okay. So the plus still goes in the front. I have a negative 25 now. when I divide by negative 25, I get negative 25 divided by negative 25 is positive 1x. Negative 25 divided by negative 25 makes a positive 1. Okay, so I started originally with 4 terms. Now, though, I don't have 4 terms. Now I only have 2 terms. That's the first one, and that's the second one. I only have 2 terms. Okay? Now, out of those 2 terms, the green and the purple, do they have anything in common? They both have an x plus 1, right? That's called the GCF, right? If you have something in common, if they both share something in common, that's called the GCF. So what I'm going to do is I'm going to write that GCF out in front, in parentheses. X plus 1. Now, when I use a GCF, they lose them, right? They always lose whatever they had before. So those x plus 1s go away. Now I'm going to write the leftovers. What's the leftovers? What's the leftovers now that I haven't used? X squared plus a negative 25, which is the same thing as minus 25, right? Plus a negative means just subtraction. Okay. So I'm here now. Okay. So now the leftovers are in there. The GCF was x plus 1. The leftovers were x squared minus 25, right? My last step for factoring is difference of squares. Are either of those guys difference of squares? Are either of those guys have a square, a minus in the middle, and perfect squares? Well, we'll start with x plus 1. Is x plus 1 difference of squares? No, right? For a lot of reasons. It needs a squared and it needs a minus. If it had those two, it would be difference of squares. So x plus 1 can't do difference of squares with. How about x squared minus 25? Yeah, that one's difference of squares. Because a 1 in front, right? X squared, a minus, and 25 is on my list of perfect squares. So that one breaks down to x plus 5, x minus 5, along with x plus 1 that I already had. That's it. You're done. If it's factoring, we don't have to do the last step. The last step is only for solving, and this one didn't say solve, it just said factor. Okay. All right. Okay, let's go to number 2. Let's go to number 2. Again, it says factor completely. It's got 4 terms, so we have to use grouping. Okay? That's when you have to use grouping. If it says factor and there's 4 terms, we have to use grouping. If it's 3 terms, we could use those steps on the board. If it's 2 terms, we can use those steps on the board, but we can't if it's 4 terms. So we're going to use grouping. So first thing, overall GCF. Is there an overall GCF between all 4 of the terms? Is there anything I can divide all of them by? No. Close, but no. If that negative 5 here was like negative 6 or negative 4, then I could divide them all by 2, but no. Okay. Is it in standard form? Check. Okay, so let's split them into 2 groups. The first 2 go in one group. Plus in the middle. The second 2 go in the other group. Okay, so now let's look at the first group. What is their GCF? What is that GCF between those two guys? Just those two guys. Well, first of all, how many powers do they share in common? 2, right? They both have at least 2 I could give up. And then 2 and 5, they don't have anything in common. 2 and -5, I should say. All right? So x squared is going to go in front. When I take away 2 powers, that just makes 2x. When I take away its powers, it doesn't have any x left. It's just got a -5. Okay. Now the next one. Here's kind of a secret. The secret to this, the second one, is we want to make it look like this guy here. We want to make it look like this guy here. So what do I have to divide by to make it look like that guy? -2, right? Yep, -2. That's kind of the secret, because if those two guys aren't the same, then I can't go on. So they have to be the same. So when I divide by -2, I get 2x minus 5, which is what I wanted. Okay, so I have one term here, one term here. So I only have 2 terms now. I started with 4, now I have 2. What do they have in common? 2x minus 5. They both have a 2x minus 5. One there and one there. That was their GCF. Now the leftovers. The leftovers are everything we haven't used. X squared minus 2. Okay. So that takes us down to the last factoring step, the last step before the second to last step, which says difference of squares. So are any of these guys difference of squares? So remember, difference of squares, I needs a squared, it needs a minus, and both of these numbers have to be on my list of perfect squares, right? I have a 1, 4, 9, 16, 25, 36, 49, but it goes on, right? Well, 2 isn't on my list, 5 isn't on my list, and there is no square. So that guy is not difference of squares. Over here, though, I'm close, right? I have a squared, I have a minus, there's a 1 in front, that's on my list, that's the first number on my list, but 2 is not on my list. So it's not difference of squares. It's close, but it's not difference of squares. So because of that, I am done. Okay, just be careful with that. A lot of times when you see difference of squares, you're like, oh, it's got a squared, it's got a minus, it's difference of squares. No, it has to be, the numbers have to be perfect squares. 2 is not a perfect square. Okay, so we'll be done there. Okay. Okay, so what I want you to do now is do number 3. Try number 3 on your own. Try number 3. It's also another factoring question. Okay, so we have some pretty big numbers here, but there's no overall GCF. Overall, there's no GCF. Okay, so I got to, and it's in standard form. Group the first 2. The first 2 get their own, get their group. Always a plus in the middle, and then the second group. Okay, so the first group, we want to pick the GCF, the greatest number they share in common. Well, first of all, they share x squared in common. So that's going to be x squared. But the biggest number, they definitely share 4 in common. I think they even share 8 in common. No, not, maybe 8. But what's the biggest thing they share in common? 16, yeah. If you don't pick the GCF, it'll mess up the next step. So just make sure, this is usually where the mistakes are made. The biggest GCF is not picked. Okay, so just make sure you're going for the biggest thing. Okay, so we got 16x squared. If I divide it, I get 3x plus 7. Because 16 goes into 48 3 times. I take away 2 powers, that leaves 1 power of x. 16 goes into 12 7 times. If I take away both powers, it has no more powers of x. It has no more x. The second one is close. Negative 3x minus 7. It's really close to being x plus 7. I just have to divide by negative 1. So my GCF is going to be negative 1. So it would be 3x plus 7. Okay. So now I have two terms. I got that guy, and I got that guy. What is their GCF? 3x plus 7. Leftovers, 16x squared minus 1. Okay. Last step, yeah, difference of squares. Are any of these guys difference of squares? Well, this guy right here is not, because it's missing like everything. It doesn't have a squared, doesn't have a minus. 3 isn't on my list of perfect squares. 7 is on my list of perfect squares. So this guy is done. But this guy here is difference of squares because 16 is on my list. 1 is on my list. It's got a squared and it's got a minus. So what is this guy going to break down to? There you go. 4x plus 1. 4 because that's the square root of 16, and x because that's the square root of x. And then 1 is the square root of 1. And then I have to have the opposite one, 4x minus 1. And then the one that wasn't difference of squares, I still have to write down. 1 box. Factor, 1 box, all of them just like that, you're done. Okay? That's factoring. The last two are solving. The only new thing I'm going to do is that last step. That's it. Everything else stays the same. So you're literally not going to do anything different until the very end. Okay? Okay, so overall GCF, no overall GCF. It's already in standard form. Split into 2 groups. Okay, so let's split into 2 groups. Plus in the middle. Okay. So now we look at the first group. The first group has a GCF. They both share at least x squared in common. But 4 and 7, no GCF. Okay, so it's just going to be x squared. So we have x squared, and then it's going to be 4x plus 7. All right, so the second group. Well, I want to make it into 4x plus 7. So what do I have to divide by? Negative 3, yeah. Negative 3. 4x plus 7. Once those two guys are the same, I'm happy because then I can do my next step. My next step is, okay, what do these two guys have in common? They got a big GCF, 4x plus 7. That's what the definition of a GCF is. What do they share in common? These guys share a 4x plus 7 in common. Leftovers, x squared minus 3 equals 0. Because plus a negative just really means minus. Plus a negative 3 just means minus. Okay, that's where I stopped last time. Or actually, no, I haven't done my last step. Difference of squares. This guy is not difference of squares. Is x squared minus 3 difference of squares? No, it's really close. but 3 isn't on my list of perfect squares. 4 is. If that was 4, that would be difference of squares, but it's not. Okay, so that's where I would be done. But now I have to do the next step, which we've done before. All of the things in parentheses, set them equal to 0. We've done this before many times. How many total answers should I get? 3, because remember at the very beginning, the biggest power was 3. That means I should get 3 answers at the end. Okay, so let's do the first one. Subtract 7 from both sides. Divide by 4. I get x squared equals negative 7/4. Leave it like that. Don't need to change it to a decimal. You don't need to reduce it. You're done. Okay, now the other guy. Add 3 to both sides. X squared equals 3. So how do I undo the squared part? Square root, right? So if I were to go to my calculator and do the square root of 3, if I were to go to my calculator and say, what is the square root of 3? 1.7320, it's an irrational number. It goes on forever. And in the directions, they didn't say anything about rounding any answers. So what you're going to do is you're not going to round the answers. You're just going to leave it like that, the square root of 3. But we said this guy should have 2 of my answers. So where do I get the 2 answers from? Plus and minus, right? Plus and minus. Anytime you take the square root of something, you're going to have 2 answers, a positive and a negative answer. So you can write it like that in Delta Math with the plus and the minus, or you can write it like this. That's okay too. You can write it with just the square root of 3 and then one with the negative in front. That's okay too. Okay. All right, let's do one more in the notes and then we'll do a couple practice problems and we'll be done. Okay. This one says find all real solutions. Solutions mean solve. Anytime you see the word solutions, that means solve. So we have to solve. So we're gonna, and it's got 4 terms. It's got 1, 2, 3, 4 terms. Okay. So factor out a GCF. A total GCF they don't have. It is in standard form. So let me split it up into 2 groups. Okay. GCF for the first guy is going to be x squared. So that leaves 2x plus 3. GCF for the second guy, we want to make a 2x plus 3. That's what we need to make. I need to divide by something that would give me a 2x plus 3. So it's going to be something pretty big to reduce those big numbers. 25, yep. It's going to be 25. 25 goes in there and 25 goes in there. So it's going to be positive 25 on the outside, 2x plus 3. Okay. I have 2 terms. Their GCF is 2x plus 3. So I'm going to write that down. The extras is x squared plus 25. The leftovers is x squared plus 25. Okay. Difference of squares. That guy's not difference of squares. This guy is really close to difference of squares, but what part is wrong? The subtract. It needs to be subtraction, yeah. If it was subtraction, it would be difference of squares. X plus 5, x minus 5. But it's not, so we leave it alone. So we go to the last step, which is separate, set equal to 0, and solve. Subtract 3 from both sides. Divide by 2. Okay. And then over here, divide by subtract 25 from both sides. When I take the square root of negative 25, what's the square root of negative 25? 5i, yep. We got to include the I since it was a negative 25. But it's got to give me two answers, right? You got to need two answers. So it's going to be plus or minus 5i. Positive 5i and negative 5i. There are my three answers. Okay.